All right, so welcome back to another lecture on Introduction to Computer Programming. So in this lecture, we'll be looking at data types and the operators. Here is the outline of our presentation. We've got Python data types, then typecasting, arithmetic operators, assignment operators, operator precedence expressions. So the first thing that I'm going to do, I'm going to make a presentation. I'm going to give you this particular lecture. Then after that, I'm going to make a presentation whereby I'll be presenting some codes, how to code, how to write a program in relation to what we are going to work on today. Python data types. So in programming, data type is an important concept whereby it's there to enable you to write an application, to write a program that will be able to get input and give the output or give you the desired output. So it's a very important concept. Variables can store data of different types and different types can do different things. For instance, if you've got integer type, we know this could be added, they could be subtracted from, they can multiply one another, and so on. If they are strings, you can concatenate them, or else a particular string will simply give information to the user that the data that has to input should relate to what he has been instructed to do. Python has the following data types built in by default in these categories. You should also know that we can create our own data types using objects and methods. Text is of type string. So text is of type string. Numeric is of type integer or float or complex number. We are going to look at all these. Sequence types, we have got list, tuple, range. Mapping type, we have got a dictionary, but it's known as dict. Set types, we have got set, frozen set, as it is in mathematics. Understand that we have got some sets. We have got boolean, bool, where we are looking at true or false. Binary types, we are looking at bytes, size of files, byte array, memory view. These are some of the data types that we'll discuss. So the first data type that we're going to discuss is the string. So a string is simply any grouping of characters you place within single, double, or triple quotes. So as I said before, that strings are put between quotes. So it could be a single quote or else a double quote. If you say double quote, it means now we're looking at we've got single quotation marks, we've got double quotation marks, and also have got triple quotation marks. Strings in Python are surrounded by either single quotation marks or double quotation marks, as I said before. So here an example, hello, and also this one is double what? So hello is the same as hello. You can display a string literal with the print statement, the print method. So this is a print function. And for example, we would print hello, or a is equal to hello. If we print a, so the same output, you have the same output as for this and also as for this. This one is going to print hello, and also this one is going to output hello. We also have got string concatenation, whereby they can be concatenated. So the meaning of the operator may change based on the data types of the values next to it. So in this case, we have got a plus symbol, and we have applied this particular operator on the strings we are referring to as these are going to be connected to one another. So for instance, we have got Alice plus Bob. Here it gives us Alice Bob. For multiplication, we just want to replicate what we have provided. For example, if you have got the name John, then you say John times 5 is going to give you John 5 times. So like in this case, we've got Alice times 5. It has given us 5 Alices. That is 1, 2, 3, 4, 5. numeric type. So there are three numeric types, as we all have already seen: integer, float, and complex. Now the integer is simply a whole number. So if you assign it data type, or if you cast the data type of integer, it is integer, and if you write 3.5, it will give you 3 or 4 if it's there to round it up. So you can either have a whole number which could either be positive or negative, and this doesn't have decimals. Any whole number is an integer. So for example, 1 is a whole number, so it's an integer. On the other hand, 1.0 isn't a whole number. It has a decimal part to it, so it's not an integer. So integers are simply whole numbers, but it's a numeric value. For example, I've got x is equal to 1. Then y is equal to, all this what we see here, z is negative. All these are integers because they don't have any decimals. And when you print all these, if you want to find the type, it's going to give you int type. So I'm going to demonstrate all these later on. Another part is a float or floating point number. Is a number, positive or negative, containing one or more any number that includes decimal portion. Any number that includes a decimal portion is a floating point value. So for example, 1.0 has a decimal, so that's why it's a floating point value. In this case, we have here what float can be scientific numbers with an e to indicate the power of 10. So for instance, for good, x is equal to 1.10, y is equal to 35 to the power of what? To the power of 3. So okay, 35, you say 35 is 3, it means now this is to the power of what? Power of 10, but it could be multiplied by 3, understand? So z is equal to negative 35.59. So if you print that data type, is going to give us float data type. Then the next data type under float is complex numbers. So complex numbers are appended with a j. Complex numbers consist of a real number and an imaginary number that are paired together. Complex numbers are written with a j as the imaginary number. X is equal to 3 plus 5j, y is equal to 5j, z equals to 5j. So if we type the data type, they are going to give us a float, which is a complex number. Now it may happen that in the first place you have assigned a value with so you have assigned that particular value with a whole number, which is integer, but now you want to change that integer into a float. So we call that one as conversion. So you are changing from one data type to another data type, in this case under the numeric data type, so integer, float, and complex. For instance, we have x is equal to 1, then y equals to 2.8, which is a float, z equals to 1j, which is a complex number. Converting from integer to a float, that is possible. So in this case, we've got a equals to float x. So what is going to be printed? It will be 1.0. If you print this one, it's going to give us 1.0. Since we have changed, we have casted it. So this is what we call casting. So we have casted it into a floating number, float point number value. We can convert from float to integer. So we can simply say b equals to y. So this y, so it's give us, it's either is going to give us 2 or else it's going to give us 3. Complex, the same thing is going to happen. So there may be times when you want to specify a type on to a variable. So there are some times you just want to assign the type to a variable, that you want to come up with. So casting in Python is therefore done using constructor functions. So in this case, we've got integer, which constructs an integer, float constructs a float number, string constructs a string number. What it means is that since we said that in Python, when we're declaring a variable, we should first of all assign a number, and we don't explicitly assign its data type. But if you want to assign its data type, then you can use what we call casting. It means now the type, right? So the variable that you have declared, you can assign it, you can cast it. It could be an integer, could be a float, and so on. Here is an example. X is equal to 1, meaning that this is going to be an integer. X will be 1. Y int 2.8 is going to be 2 because it's an integer. It capitalizes on numbers. For this one, int, even if you have put it in quotation marks, it will be converted into an integer. The examples of casting in floats is as we see here. So this is going to be 3.0, this is going to be 1.0, this is going to be 2.8 as it is, this is going to be 4.2. So the last two have been converted from string to a float. So we are able to convert these ones from string to a float because they are not characters like letters APC. But if you try to put an ABC here, it's going to give you an error because it doesn't know that that is a numeric value. The same thing applies here. So for example, x is equal to str s1. X will be s1. We are converting these, we are casting these ones into a string. For str2, this one of course will be converted into a string, of which it will be in quotes. The same thing applies here, it will be in quotation marks. The Python operators, so every data has to be processed. For that particular process to take place, there must be some operators that have to work on them. If you remember in our last semester's lessons, we talked about logic units, whereby data was being worked on. As we said, that data in a computer is represented by ones and zeros. So those, but combination of all those zeros, it was more like adding, which is an operator, plus a symbol is an operator, then subtraction is an operator, multiplication is an operator. So the same thing applies to numeric values. So Python divides the operators in following groups. So in this case, we've got arithmetic operators, assignment operators, comparison relation operators, logical operators, identity operators, membership operators, and bitwise operators. So let's see how they work. As it says, arithmetic operators are used with numeric values to perform common mathematical operations. So here is the example where we've got the unary operator. So it adds its f to it, meaning unary positive. Hey, in other words, it doesn't really do anything. It must exist for the sake of completeness, to complement unary negation. Then we've got plus this binary. So example would be a plus b. This is an addition. So this is the type of operator, which is an addition. We can assume a plus b addition. Sum, we are summing up the two variables, two values. Then we've got unary negative, unary negation, value equal to a but opposite in sign. But usually these ones are used if you want to, maybe you are looping some figures, then you keep, once if you loop, you should make sure that they add to themselves. So that's why this one is applied. Multiplication, the same thing. Division, it means we are dividing two things. Percentage, we want to find the remainder of those two numbers between the divisor and the divisor and what's this number, the one on which maybe the division is being taken quotient. When a is divided by b, the result always has type float. Yeah, so the result will always be type float, because as you are making all those divisions, there could be some remainder. So you simply put some decimal points on. Modulo, you find the remainder. this is a floor division, also called integer. So in the case of this one, no matter what you get, if there must be a remainder will be displayed. Quotient, when A is divided by B, it is rounded to the smallest whole number. So that's what happens. For this one, it says that this is a power symbol, right? So for instance, we have got A times, it means now this is A to the power B. It's an exponential. So it's used for exponential. Exponential. A raised to the power B. Arithmetic operator precedence. Yeah, so in the case of precedence, when I explain, we have done this in mathematics, whereby we start with the parenthesis, then we may go further to the powers, to the exponential, then we have got multiplication. So what follows is modulo, division. These are the ones which have got higher precedence than addition and subtraction. So you will see that here A is addition and subtraction. But now, if the operators are at the same level, they are close to each other. So the precedence goes starting from the left. If you have got 7 plus 5 minus 2, it means it begins from the left. You start with the first two numbers that are going to operate on themselves, like if there's a plus, then after making the addition, they need to go further, make a subtraction. The same thing is the vice versa. What happens is that if you have got the 9 minus 7, then plus the 2, it means now it has to subtract 7 from 9, then finally it has to add the 2 remaining numbers. The sum, the result, and the other remaining. As it says, operators with the same precedence are evaluated from left to right. These are the assignment operators. So if I got a single equal symbol, we are saying that x is equal to 5. It means now x in its container is carrying 5. This is just the same as x is equal to 5. We have got plus equals to. So just the same as x plus equals 3. So this one is just the same as x is equal to x plus 3. It's like you are assigning a value added with the variable itself to the variable itself. The same thing applies here. X times equals to 3, just the same as x is equal to x times 3. Division, the same thing. Modulus, the same thing. Division, the same thing. For this one, yes, the same thing. And also the same thing. The same thing up to the end. So here we are saying that x or is equal to 3, x is equal to x or 3. See, for this one, oh yes, just the same. We'll put an and. This one is also a power symbol. What we are saying is that it is x to the power equals to 3, just the same as x to the power what? 3, as it is here. The same as it applies here, x plus 3, we get back the results to x. Here is greater is greater than is equal to greater than or is equal to or is equal to 3. Just the same as it appears here, and so on. Now, so what about comparisons? Yeah, on comparisons, this is what we have. Comparison operators are used to compare two values. We have got equals, it means x is just the same as y. Not equal to, x is not equal to y. Greater than, that's what we've seen here. less than, as it is. We have done all these in mathematics. Expressions in Python. An expression is a combination of operators and operands. So that is interpreted to produce some other value. An expression is a combination of values, variables, and operators. So what are these variables? Variables I'm referring to values, or variables I'm referring to the data that we want to work on it. For the operators, these are the symbols that we use that the data should be operated on. So if it is addition, so if we combine values and the operators, we call that one as an expression. For instance, if we say 5 plus 5, that is an expression because we have got values, we also have got an operator, or could be operators. A value all by itself is considered an expression, and so is a variable. So an expression is evaluated as per the precedence of its operator, so that if there is more than one operator in an expression, their precedence decides which operation will be performed. So if you have got a combination of multiplication, subtraction, and so on, it means one of them has to start operating depending on the precedence that has been given. So if you have got multiplication, you start dealing with the multiplication part, then you end up with the addition part. We have many different types of expressions in Python. We also have got constant expressions. So these are the expressions that have constant values only, they don't change. So you have constant expression. If you say x is equal to 15 plus 1 is equal to that, I think it can change at any time, because we are not seeing anything that talks about what that mentions const, but I think you can assign it a value so that it could be used wherever you want, because it's not going to change. An arithmetic expression is a combination of numeric values, operators, and sometimes parentheses. So the result of this type of expression is also numeric value. So the operators used in these expressions are arithmetic operators like addition, subtraction, etc. We have got these variables. So here what we are saying that add, we are adding x plus y, subtract x minus y. What is pro? So it's product, x times y, division, x divided by y gives us the result. We may also have got multiple operators in expression, so that's what happens. So precedence is going to take place. So all these that we have here are some of the operators that we are supposed to work with. We have got parentheses where the precedence is forward, but if these parentheses are on the same level, they begin from the left. Exponential, plus multiplication, shift operators. So these are the shift operators. Sorry, I made a mistake in the other slide. Bitwise and bitwise XOR this one, bitwise or that one. Comparison operators. So these are the ones that we have, so on. All right, so this marks the end of our lecture. So let us move on to our demonstration.